Okay, hi everyone. We're going to look at an example of correlation and regression and how to use our TI-84 calculator to calculate that. Now we're just going to go fairly simple here. We're not going to do residuals or R-squareds. If you need to know about any of that stuff, I will recommend you another video in the description. Here we're just going to look at simple correlation and regression. Here's the scenario we're going to use. Some school administrators want to see if the size of the class will affect the grade. They collected some data and now they have 4 questions for us. Are the two variables linear related? How strong is the relationship? What is the equation of the line? It models the relationship, and we're going to use that equation to predict what would happen if there were 13 students. Okay, so let's see how we can use our calculators to solve all these 4 problems. Okay, before we do that, we're going to do some stats. So just press your mode button and make sure, let me make it bigger, make sure we have our stat diagnostics on. If not, arrow down, arrow across, press enter. Okay, also we're going to go to the memory, so quit. We're going to go to memory, which is above the plus, second plus. And we're going to clear all our lists because I know I have some old questions there that I don't need anymore. So I'm going to clear all my lists. Enter. Done. Now I can start my new question. Okay, so I'm going to enter some statistics. So stat, edit. And now I've got to think quickly about which one's X and which one's Y. Well, I think, and I think this is what the school administrators think too, is that your grade depends on how big your class is. Okay, so we always have the X value as the independent variable and the Y value as dependent variable. So if grade depends on class size, then grade is the Y. So number of students is the X. So we'll put that first. Alright, so 15, 10, 8, 20, 18, 6, 22. Okay, then we'll go across, enter. Go across to list 2 and do the same. 85, 90, 82, 80, 84, 92, 83. Now we just quickly do a double check that all our numbers are correct. Now we have the same number of numbers in each column because it won't work if the columns are different sizes. Okay, now we can do that. We can answer the questions. Are they linearly related? Well, the best way to check that is to draw a scatter plot. So let's make the big screen and we'll see. So we're going to do a stat plot. So we go second y equals, stat plots here. I'm going to turn this plot on. Plot on. What type is it? It's a scatter plot, so it looks like that. We're going to use list 1 and list 2. You can enter the list by hitting the blue button and then see down here it has L1, L2, L3. You pick the lists you want. You can change the style to different styles. I just like the boxes. That's great. And color blue. Blue's a good color. Alright, so now I just press graph and I don't see anything. So what am I going to do? I'm going to press zoom and number 9 for zoom stat. And there's my scatter plot. Excellent. Now, is there a linear relationship here? To me, I would say yes. It looks like you could draw a line through here and show that as the class size increases, the grades decreases. There's a few outliers. Well, it doesn't quite form a perfect line, but it tends to suggest there is some relationship. So let's call that yes, a moderately negative correlation. How strong is that? Well, it's moderate. Let's be more specific. Let's calculate. So stat, calculate, and we're going to use linear regression. That's number 4. You see number 8, it's exactly the same thing. You could use number 8, but I prefer number 4, and we just use the same thing every time. Just use number 4. Okay, we put in our X list, list 1, Y list, list 2, and it's good to store the regression equation because we're going to use the equation down here twice. So store a regression equation. Two ways you can do this. Hard way is, well, we want a variable, so we press vars. We want the y variable, so it's y vars. Function, so it's number 1. And let's just pick one, pick y1. Okay. The quick way to do it is press F4, which is alpha trace. And you can pick your y variables there, y1. Okay. I'll show you what this means in a second. If you need to see this, just rewind the video and watch it again. Okay, then we enter to calculate, enter, and here is our information. This R value here tells us how strong the relationship is. Our relationship has an R value of negative 0.667. So that's moderately strong. Oh, sorry, moderate. Okay. Number C, what's the equation of this line? Well, that's given to us here as well. Y equals AX plus B, where A is negative 0.464 and B is 91.7. So there's our relationship. Now, you'll remember a few seconds ago I stored it in Y1. So I stored this equation here with all the decimal points is what I've just written down here. You can see that, negative 4.64x plus 91.7. So now when I hit the graph, it puts the line in. That's awesome. Now, if there was a class of 13 students, what do you predict their average grade would be? Two ways you can do this. Okay, we can quit this and just, hopefully we've written this down somewhere and you can retype it in. Okay, and as you can tell, I'm already getting a little bit frustrated doing this. So, hasn't there got to be an easier way on my calculator to do this? Well, yes, there is. If you've graphed it, okay, this word here, calc, it'll calculate it for you. Second calc, I want to calculate a value. I want to calculate the y value when x equals 13. Boom. You can see it there. Let me zoom it out for a second. X equals 13, y equals 85.7. So we would expect someone to get 85 points on average, to get 85.7% if they come from a class of 13 students. So that's a very simple correlation and regression example. I'll link to another video that shows you R-squareds and residuals and discusses that. But for now, good luck with the questions you're solving. Bye.